Alright, today we're going to be covering different topics of ratios, proportions, and percentages. So let's get right into it. So, a ratio is used whenever we're comparing two numbers. One way that you know that you're going to be using a ratio is whenever they use the word to, the colon, or a fraction. Something I do also want to point out. Ratios and fractions, sometimes there are interchangeable, but I will be getting into more in detail that there are some differences that we do need to take into account. So let's say someone says, let's say you're making a DIY disinfectant at home that is 1 part bleach and 10 parts water. So you would say 1 to 10 ratio of bleach to water. So it's bleach, since it's the name or the label that comes before the word to, it's going to be the one also in front over here in the ratio. Water, we know it's going to be the equivalent to the number 10. Also, if someone writes it out like this, if you go ahead and say it out, it means 1 to 10 ratio. Now let's do this as a fraction. Now the way that we're going to write this is like this, 1 over 10, and not 10 over 1. The reason being is that the number that comes in front of the word to, this is going to be your numerator. And then the label that comes after the word to is going to be your denominator. So by this logic, 10 is water, and 1, which is your numerator, is going to be bleach. Alright. Something else I want to point out is with fractions we try to simplify it. Like if we have 50 over 100, simplify it to 1 over 2. Same thing with ratios, that is also true. Okay, I'm going to go ahead and erase this. So let's go ahead and do a word problem with ratios, and then knowing with this word problem, we're going to go ahead and simplify to lowest terms, basically make it into a more concise measurement. So let's say that you are Johnny. Johnny works in a pharmacy. During his 8-hour shift, there were 25 cash sales, and 15 credit card sales. What is the ratio of credit card sales to cash sales? word problems, there's always, it's very common for it to have extra information. Johnny works in a pharmacy. Alright, that's nice to know, but we don't really need to know that. Just clean up the clutter. During his 8-hour shift, there were 25 cash sales. Alright, so 25 people, or there was 25 transactions that people paid with cash. Or there was 15 purchases that people paid with a credit card. And then right here it's asking for the ratio of credit card sales to cash sales. During his 8-hour shift, that's an extra number that they're just throwing in there for extra information. You might be tempted, if you weren't so sure of yourself, of like throwing that in somehow into the calculation. Just because the number is there doesn't mean you have to use it. Same thing here. Just throw out a little humor. Just because an item's on sale doesn't mean you need to buy it. Alright, so we got 25 cash sales and 15 credit card sales. Alright, so here with the ratio, it's talking about credit card sales to cash sales. So credit card sales, we have 15. So we have, let's actually write this up here instead. 15 credit card sales to 25 cash sales. Alright, so basically I already went ahead and rewrote this information, but I rewrote it in the way that the question wants it. So I can just go ahead and do this. Now let's say our answer choices aren't in words, but they're just like this instead. We need to be sure how to convert this. Since the question is asking from credit card sales to cash sales, we can just go ahead and just drop these down and do 15 to 25. Now, this is where a lot of people get into trouble, is if the question is asking for cash sales to credit card sales and you don't flip the numbers corresponding to it. That's why I really want to encourage you to label, label, label. With fractions, you might not need to label as much, because fractions, like your numerator and your denominator. So like, let's say I have like a pizza. And there's 8 slices. And let's say I ate 3 slices out of 8 slices. It's already implied that, well, I'm talking about 3 slices out of 8 slices. The unit of measurement for the numerator and the denominator is going to be the same. Slices, slices. With fractions, let me go ahead and just write this out. With it's supposed to be a W. With fractions, both the numerator there we go. With ratios, I can talk about slices. I can say 3 to 8 slices. from for every 8 slices that I buy, I'm going to eat 3 slices. That's fine with ratios. I can use totally the same unit. Or I can use different, because a credit card is visibly and very obviously different from cash, even though you could argue that they do the same thing. A credit card is different from a green dollar bill. So ratios can have either the same or differing units and that is because ratios compare numbers, and when you're comparing, you can compare one apple to another apple, or you can literally compare apples to oranges. Alright, so now that I've made that explanation, let's go back over here. So I'm going to go ahead and erase all of this, and I didn't realize that that was not showing. I move the camera ever so slightly. Yes, there we go. Okay, so whenever you're having to do like actual calculations with ratios, and they're the same unit of measurement, you can just rewrite it like this. Much more easier for what we're going to do next. So we know that the number 15 and number 25 are both multiples of 15. Both have multiples of 5. So 15 is the same thing as 1 times 15, or 3 times 5. We also know that 25 is equal to 1 times 25, or 5 times 5. So what is a common multiple they have, which would be on this side of the equal sign? They have both. So 15 has 5, and 25 has 5. It doesn't matter. I can circle this 5. 5 is 5. So then here, what we remember from our fractions lesson, we can go ahead and if you divide anything by 1 or even multiply by 1, it's going to be the same value essentially. So if we have 5 over 5, that is the same thing as 1. So I'm going to divide by 5. Divide by 5 top and bottom, because whatever we do to the top, we got to do to the bottom whenever we're simplifying. So now that I do that, 15 divided by 5 is 3. And 25 divided by 5 is 5, so we get 3/5. Ta-da! So, with 3/5, I can either, let's say that Johnny has to talk to the lead pharmacist, and the lead pharmacist asks him, hey Johnny, so like, what's the ratio between credit card sales to cash sales? We're trying to decide whether or not it's worth it to accept credit cards. And Johnny could say, well, for every 15 credit card sales, there's also 25 cash sales. That's a lot, especially when you're dealing with larger numbers. If you could say, for every 3 credit card sales, we have 5 cash sales, it's a lot easier to operate in your head. So you could say, well, it's like a little bit more than half, because 3 is more than half of 5. So for those of you who are always wondering, like, well, why do I need to know this aside from testing on it to have to pass my high set exam so I can have my high school equivalency degree? Well, you use a lot of math and decision making, and this is an example where it comes into play. So I'm going to go ahead and erase this. another example with ratios. So let's say that a soccer team won 12 games this season, but lost 8 games. There were no tie games. What is the ratio of games won to games played? Alright, so this is a two-step problem. We have here, in the problem itself, it's already telling us games won, so let me go ahead and just rewrite all this. We have games won, 12 games won. We have 8 games won. 8 games lost. But here in the question, what it's asking us to solve for is the ratio of games won to games played, not games lost. Like, well, I don't see the word games played, so like, I don't know how I'm going to get it. You can actually get this from just this information. And being able to make these decisions part of critical thinking, which is a skill, it actually makes a difference later on in the workforce whenever it comes to pay grade and also what kind of responsibility you can get later on. So these are the games I won, these are the games I lost, and I also know that there was no ties. So I can therefore induce that I can add up the games that I won with the games that I lost, and those are the games I played. Let's go ahead and add them up. I get 20 games played. So I just want to order this out. I've got ratio of games won to games played. 12 games won to 20 games played. Alright. So since I have my information in the red, is basically a copy of what I have in blue, I'm going to go ahead and erase the blue. I'll go ahead and adjust the camera as well a bit. Yeah. Alright, so we could, if one of the answer choices was actually spelled out like this, great. But let's say the answer choice comes in form of a fraction. Like, well, games won and games played, they're like two different things. Yes, but we could still write in a fraction because we're still talking about games. So let's write this as a fraction. We know that what's to the left of the word 2 is what's going to be in our numerator. And what's going to be to the right of the word 2 is going to be our denominator. So we're going to write this over like this. 12 over 20. So now that we have that, we're like, great. But I can simplify this further. And like, woohoo! So let's go ahead and list out our multiples. We have number 12 over here is equal to, actually I'm going to give myself a little more room. I'll go ahead and do it down here. 12 is equal to 12 times 1, 2 times 6, and 3 times 5. Next, we have number 20. 20 is based on the multiple of 20 times 1, 2 times 10, and then 4 times 5. Also, I could say 5 times 4, and then 10 times 2, but forwards and backwards, it means the same thing. So what do they have in common? So they have 2 and a 2 in common, but if I look further down, they have a 4 and a 4. Like, great. That makes it even more simplified. Because let's say if I choose a multiple over here that matches between these two numbers, and I ignore like a greater multiple that was further down, I'm going to have to end up simplifying yet again. And we don't like doing things more than once. So if we can just get it all done in one go, let's do it. So we got 4 and 4. So let's divide by 4 for the numerator and the denominator. So let's divide by 4. Divide by 4. And this 12 over 20, what we're going to calculate, what we're going to compute over here is going to be the exact same value. 12 divided by 4. I don't actually got to think. I actually wrote it down over here. 3. And then over here, it was a 5. 20 divided by 4 is 5. This is my final answer. So I can even say the team won three games for every 5 games played. That's not bad. Now, since this is a very easy number to deal with, before we get to percentages, I will say 3 over 5 is the same thing as 60%. So the team's not doing too bad. But if they want to get into like nationals or anything like that, they might have to improve their game. Alright, so we discussed the first part of the ratio and proportion lesson. Now we're going to get into proportions. I'm going to go ahead and erase this. Alright, so a proportion, by definition, proportion. By the end of this, you guys are going to be pros at proportions. So a proportion is an equation. Not just because you hear the word equation, don't panic. An equation that shows that two ratios are equal. Now, this is something I do want to mention with math. If math builds on itself, like if you don't have the foundation or you're shaky kind of on one level and you try to move on to the next level without enough mastery, if you didn't master the ratio section, you're going to have problems with proportions. Because even here, with the whole basis of proportion, it's an equation that shows that two ratios are equal. So I really encourage you that if at this point you're not comfortable with proportions, go ahead and rewind and watch the ratios, or go ahead and just go ahead and send me a message and we'll cover that more in detail. Okay, so what does this mean in English? Okay, so this means when you multiply diagonally across the equal sign, the products are equal. let's go ahead and demonstrate this. Let me go ahead and erase. And I need to do a word problem. Okay. So we have a recipe. A recipe requires to add 3 cups of water, to every 2 scoops of a drink mix. Mark adds 12 cups of water to 8 scoops. So this is for maybe like a protein powder or a protein shake. Probably should have said protein instead of a drink. Unless you're into like electrolyte drinks like Pedialyte. So here we're going to go ahead, there's 2 different ratios. There's what the recipe says, 3 cups for every 2 scoops, or 12 cups for every 8 scoops. Now, here's the actual question. Did he make the protein drink correctly? Alright, so let's go ahead and set this up. We got 3 cups and 2 scoops. And before any of you start shouting heresy that I just said, well, with fractions you can't have 2 different units. You can, as long as you label it. So here we have the actual recipe. 3 cups for every 2 scoops, golden. This is what we want. So we're going to put this on the equal sign because we're assuming that he is correct. Now, like, well, miss, it says, is he correct? Why are we assuming that's totally wrong? Well, here is something with math. We can go ahead and set it up to assume that it's equal, and we know right now in our heads that it's equal. And then if it doesn't match up, we're just going to go ahead and put a slash through it, and we're going to say it's not equal to. We're going to give the benefit of the doubt. Think positive. Think positive. So here Mark had 12 cups. To 8 scoops. So here comes the definition of a proportion. 2 ratios are equal. So it will be a proportion if the 2 ratios are equal. If they're not, it's not a proportion. So what we're going to do is we are going to do something called cross multiply. Dun, dun, dun. We are going to do this. Let me use a different color. We are going to multiply these guys with these guys, and these guys with these guys. And that is the true definition of a proportion. When you multiply diagonally across the equal sign, across and below the equal sign. The products means the answer of whatever you multiply is equal to each other. So if we have 3 cups multiplied by 8, 3 by 8, is it equal to 2 times 12? Let's go ahead and simplify. We have 3 times 8, that is equal to 24. 2 times 12 is indeed equal to 24. Yay! So this is a proportion. Mark did the protein mix correctly. He was not being some muscle junkie by saying like, I can put extra scoops. He followed the recipe correctly. So here we can say this is a proportion. Now, in the exam, you might have a proportion-based question. Even if this question, the 2 ratios did not match up to each other, it's still considered a proportion question because it's testing you on your concept, on your mastery of the concept of proportions. But yes, this is a proportion, yay. Okay, so let's take this a step further. We're like, okay, so like Mark did the protein shake correctly. So what? So what is now that we understand the underlying concept of proportions, we can now solve for unknowns in here. Yes, this is starting to be kind of more like pre-algebra. This is where it becomes more power to you. So let's say, and let's just use the same example for right now. Let's say we know the recipe. And let's go ahead and erase this. And let's say we know that Mark knows that he wants to drink 12 cups worth of milkshake. It's like, okay, but I don't know how many scoops I'm going to use. So what we can do is that we're going to use X. And always a better way to make it easier is if you can do the curly X. You can just use a normal X like this if you'd like as well. But when you do the curly X, it differentiates it from the rest of your writing. So at this point, we don't assume anymore that it is correct when we set up the proportion. And let's say we change the question to read, for our visual learners, Mark wants to drink 12 cups worth of protein shake, How many scoops? Does he need? And now this actually becomes a lot more relevant and much more important to us because now we know how many scoops he's going to need. If he's finding out that he's going to need a lot of scoops, this is going to be a lot easier for him to meal prep and to like budget his grocery store list and say, hey, I know that this container of like protein shake has only so many scoops, and it'll actually say on your serving size with the nutritional facts. We'll actually be doing a lesson on that later. It can actually help him find out how often do I need to be buying something. This is where it becomes more real world application for us. Okay, so we know it's going to be 3 cups to 2 scoops. And no assumptions, we want it. We want to be certain of the number of scoops we're going to be using, so we're going to set it up to 12 cups, right? Because we're going to put, and something else I do want to point out, we could write this like that as well, We just have to make sure the numerators correspond in units. So I could say 2 scoops for 3 cups, and x scoops over 12 cups. I could do that too. It's just, this is how I write it in the problem, and it's just a lot easier for me to keep track. Alright, now that we did that, we are going to set up our equation like so. So again, we are going to cross multiply, because that is the superpower of proportions. So we're going to go ahead and cross multiply and do this. We're going to get 3x is equal to 12 times 2. I could write it as x3, but then we do curly x. This is why I said if you it's really in your best interest to write the x as a curly x, because it's still correct. I could say x3, because when 2 different values are next to each other, I am assuming that I'm going to be multiplying. If I do x3, it sounds like I'm multiplying 3, but I don't know what the other number or value is. So we're going to write the whatever we're multiplying, the value that we do know, we're going to put that in front of the unknown, just to make our lives easier down the road. Alright, so 3x. Okay, I just want x. I don't care about the 3. What do we, so here we're multiplying. What is the opposite of multiplication? Division. Let's divide by 3. And we got to do it, what we do on one side, we got to do it to the other side. That is the rule of proportions. The 2 ratios must be equal to each other at all times. So, x is equal to 12 times 2 all over 3. Let's make that look like a 3. Alright, you've got that. Let's simplify. 24 over 3. 24 over 3. That sounds very familiar. 24 over 3 is x is equal to 8. I am going to need, and in case that you did not want to be doing your cross differential analysis with your scoops and cuts and labeling each thing and then crossing out units, it's okay right here with proportions. You don't have to keep track of that. I know whatever number goes here is going to have to be in scoops, because what's on my left side of the proportion is going to have to be what's on the right side of the proportion. This denominator over here is scoops. This denominator over here is going to have to be scoops. I know Mark is going to need 8 scoops of his protein shake mix in order to make 12 cups worth of a protein shake. Woohoo! Alright, so I hope that wasn't too scary for all of you. I know ratio proportions are can get really intense, especially when you're starting to go into pre-algebra, but it seems that we have tamed the beast. Let's do another question. So I'm going to go ahead and erase after I give you 3 seconds just to internalize all of this. So 2 and 3. And let me just go ahead and move the guys closer. Alright, still talking about proportions right here. We have and this, we're going to be doing proportion, trying to solve for an unknown. So let's say we have a little map, and the scale says, let me draw a little map. So those little maps you get from your Department of Transportation, when you go on on a road trip. There you have, normally you have the north, east, south, west. We're going to be going over that in our science portion. Okay, so with the map, they usually have right here on the bottom like a little scale. And they say like, this visual amount is going to be 1 inch here on the map is going to correspond to like 100 miles, like in reality. Because if a map was true and exact, it'd be literally the exact same size. So like if I had a true map to scale of the actual scale of New York City, my map would be literally as big as New York City. So like we actually, with proportions, we make it, but we make it even. Like if you've ever had like a picture and like you're trying to make it smaller, there's sometimes when you actually make it, you do it down to scale, like where it's proportional, but then there's sometimes like when you like do the picture like this, or you do it like this, and you end up like with like a really skinny version of the picture, or you get like a really short or squished picture of the version of the picture. Same principle here. With proportions, we make it nice and even. So here, let's say on this particular map, where it says the map scale. Now, by scale here, they mean proportion. I'm not talking about like when you go to the grocery store and you weigh like 5 apples to see like how much it is per pound. No, we're here by scale, they're talking about like their proportion. So here we're talking about the map scale indicates that 2 inches, now I'm going to be using inches because the high school exam that you're going to be taking is going to be the United States version. If you're probably taking it anywhere else that is not the United States, then I believe U.S. territories, they're going to be using the metric system principally, so that would be centimeters. Just for argument and just to be more comfortable with the American customary system, we're going to be using inches. So 2 inches is equal to 150 miles. So this is the scale. I'm not saying like 2 inches right here, which is like this big, really means 150 miles. If that was, I'd be paying an exorbitant amount of money if I ever had to use like a taxi or an Uber. So here we're just saying like 2 inches on this little map means that whatever's in between those 2 points is actually 150 miles away from each other in real life. Okay. What is the actual distance? What is the actual distance represented by 5 inches on the map? Alright, this sounds like a ratio. I'm seeing two different kinds of measurements. I'm talking about inches and miles, and then I'm also talking about inches again. Really sounds like a proportion, and this is part of the proportional lesson. So let's go ahead and rewrite this as 2 inches is the same as 150 miles. This is a ratio. Do not go ahead and start mixing this up with this. It's in a totally different sentence. So that's one clue right there. Like, don't mix up these numbers. This is one ratio. These go together. You also have to like read the question. 2 inches represents 150 miles in real life. Okay, and now we're going to go on with the actual question that it's asking. Equal to. Because whenever we're solving for something, we're no longer assuming we want it to be equal to the other ratio. 5 inches, and I'm going to put the 5 on top because I put 2 inches in my numerator over here, so 5 inches. Well, actually, since I'm not, I abbreviated miles, but I didn't have inches abbreviated, so I went ahead and spelled it out just to be uniform across both sides. So we have 5 inches, so our miles are going to be X. You could honestly use A, B, Z, or even like other Greek letters like alpha, beta, gamma. If you're so pleased, you can even use like a little cat head for all you wanted, for all you want to be solving, but just for all practical purposes, we just use X because it's the most common value that or symbol that we use for our unknowns. So let's go ahead and do cross multiplication, the superpower of proportions. Cross multiply. Okay, so we're going to multiply the 2 inches by the amount. So here's an important rule of thumb with cross multiply. You're going to multiply the numerator with the other ratio's denominator. Alright, so I've got numerator right here. I'm going to the other ratio's denominator. Alright. And then I got this numerator over here, and I'm going to multiply it with a denominator in a different ratio. So that's what we got. This multiplied with this, and this multiplied with this. I think it would be better if I point it. Okay. So let's write this out. You've got 2x is the same as 150 times 5, and we want to isolate the x because we just want to know x. I want to know what is the distance. I don't care about double the distance. I want to know the exact distance. So I'm going to divide by 2 on both sides. Again, I already said this in the previous example, but we're going to undo the multiplication right here by dividing on both sides. There is actually a little shortcut where you could just multiply and divide and you do like a little symbol, but that gets very dangerous if you're in a rush, so we're not going to focus on that yet. This is like tried and true. This is like the most effective way to go through it. But if you have any questions about that, go ahead and let me know. Alright, so we've got x is equal to 150 times 5 all over 2. Alright, so we have 150 times 5. If we multiply that, we know that it's to be 750 all over 2. So let's go ahead and divide 750 by 2. So I went ahead and calculated that already for us. So we're going to know that's going to be 375. And so it says right here, what is the actual distance represented by 5 inches on the map? Let's see on the exam it asks, it has different answer choices. We have 275. But if it says 275 inches, 275 centimeters, 275 kilometers, or 375 miles. Whew, that was a mouthful. We're going to go with miles because we started off with miles, and on the other side of the denominator, it's got to be miles as well. So it's 375 miles. Take very special care of the labels that you're dealing with. Even if you're not writing it out here when you're doing your computation, to take notice of it whenever you're using your proportion. I have actually, when I was with the different engineering teams, when we were working with different people internationally, there was an error where the customary system, the metric system was used. So instead of like saying we need like 100 feet of something, it was more like 100 meters. So the design was not the right fit. So units are very important. I think there is actually an issue with the United States aircraft, if not like the space shuttle, because there was an issue with like the customary and metric system that people were using. Because in science is going to be a whole other deal, but mostly among the scientific community, they try to use the metric system. Okay, so I'm going to go ahead and erase this. This was a fun little scale. And if you're ever on a road trip and you got to calculate this distance when your Google Maps is is dead, you can go ahead and use this. And whenever I travel, I sometimes carry like a little clear ruler. It's like, okay, let me just calculate it. And that's a great way for you to keep your math skills in motion. Alright, so next, we're going to be talking about rates. It's like, whoa, and it's like, what are you talking about? We were just going to be doing, like, proportions for this part of the lesson. Proportions are everywhere around us. So, we're going to talk about rate. Now, some of you might have a bad experience when covering rate in high school. We're going to take it slow. We're not going to be getting into interest just yet. That's going to be for a little later lesson. We're going to just work our way up. So, with rate, it compares a quantity to one. And by one, I literally mean the number one. When it's written as a fraction, the denominator is always 1. Because we know if we divide any number by 1, it's going to be whatever was the original number, which is a numerator. So right here, when written as a fraction, the denominator in this case is always a 1. Like, whoa, I can't wrap my head around that. Like, what is this? Don't worry, I've got you. Expressway, Interstate 2, which was formerly known as Expressway 83, we have 75 miles per hour as the speed limit in some places that are not under construction. 75 miles per hour. This is actually a rate. Your speed is a rate. It's actually 75 miles per hour. So you're saying that every time I'm driving and the different cities I'm going through and the speed limits are changing, I'm actually seeing rate every single time and I'm adjusting my speed so I can be driving at a legal speed limit? Yes! We are using rate! So, how does rate come into play with math? Alright, so let's go into another road trip. But this time, we are going to find out what we need in order to get to a certain distance. So, let me start with the word problem. I'm going to go ahead and erase. So, the reason I go over the actual true definition of rate is so that I can explain it like in the actual English definition, provide an example, and then cement it by yet another example in order for it to actually get in your head. So with this rate, let's say Nancy drove 276 miles on 12 gallons of gas. And by gas, I mean gasoline. If you follow British English or in European nations, they call gasoline petrol. So we're talking about here gasoline, what we put in our car. She, with 12 gallons of gas in her car, I am not an art major. Okay, we have Nancy. She's there and she's driving. So she drove 276 miles, so that's a distance on 12 gallons of gas. Alright. Seems like we're missing some more information. Is how many miles per gallon did she get on the trip? How many miles per gallon did she get on her trip? So we have miles per gallon. This is what it's asking for. Miles per gallon. And the way that we know that we can go ahead and write this as a ratio or as a fraction is because the word per. And normally we use per, not like per as in like a cat purr, like talking about per, like P-R. That means that is more than likely going to be a rate. And miles per gallon, we call that mileage. And you're like, I thought this was going to be like a math problem. Why are you doing word problems? A lot of the students who take math exams, and the reason that they might get a question wrong, most of it is because they do not have a grasp on actual definitions of what mileage means. Mileage is going to be how much miles you can get out of your gallon. They might set it up the other way. So this is where real life means book skills. You might be street smart, you also got to be book smart. But if you're just book smart, it's not going to help you when you're doing word problems. You're going to need to be a little bit street smart. Okay, so here, how many miles per gallon did she get on her trip? Oh, okay, let me just, miles, go ahead and put 276 miles. And 12 gallons, woohoo, it's already in the same unit. And this is what I get. So I can go ahead and simplify this. I can go ahead and divide this by 12. But let's make this fun. And do over 1. Here comes x. I'm like, miss, but we could have just made it easy and divided by 12. But then let's think, why do we just want to divide this by 12? Because if we divide by 12 on both sides, we get equal to 1. Right? If we do this. We're going to end up with a numerator of 1. That's what we were doing previously. We just didn't know it yet. So we could get x by doing that. But since we were messing around with proportions, we can do it like this. Just to exercise what we were doing. And don't worry, you can just do 12 if you want. But when things get trickier, this is how you want to do it. So we're going to do our cross multiplication like we were doing before. So we get 12x is equal to 276 multiplied by 1. And this is why I am doing my curly x's right here, because that is also another x. So 276 times 1, right? It means the same thing, 276. When I isolate this x, divide by 12 on both sides. We will go ahead and simplify this as x is equal to 276 divided by 12. Some of you at this point might have already like rolled your eyes like, oh, we literally could have just done that there. Yeah, we could have. And definitely do that on the exam if you know what's going on underneath conceptually. And by the time I took the exam, I would have already cleared you for this, so no problem. Just go ahead and do it directly. This is just for the sake of argument and just practicing our skills. So 276 divided by 12, we know that to be 23. And since we know that our unit right here is going to be miles, all divided by 1 gallon per gallon, you can write it like that, or we can just say 23 miles per, oh, you don't see it. Go ahead and just adjust that. Per gallon. So our answer is going to be Nancy on her 276 mile trip, where she used 12 gallons of gasoline. Her mileage was 23 miles per gallon. And this becomes very important, like when you're going to the car dealership and you want to buy a car, is you want to get more miles per gallon. Like let's say and you're like, oh man, I don't understand that. Let's use easy numbers. So let's say that we go to the car dealership and we see a car that says we get 1 mile for every gallon that we put of gas. And then there's another car that we get 50 miles for every gallon that we put. Oh, well, that's pretty obvious. So if I put like 1 gallon and in the first car, I am gonna just go a very short distance. It's not gonna be very fuel efficient. Key term, fuel efficient goes with higher miles per gallon, higher gas mileage. But if I put it in the second car, which has where I can get a mileage of 50 miles per gallon instead, that means I can actually drive drive a greater distance, for the same amount of gasoline. So that's where real life comes into play. So I'm going to go ahead and erase this. Alright, so the next section is going to be on percentages. So since percentages are a little bit more different than ratios and proportions, it's going to kind of tie back into our decimal formula. I'm actually going to include it as a separate video clip just for the sake of like whenever you're trying to review. So this is it for this video, and I'll see you next with percentages. I hope you're there 100%.